video, we'll be talking about z-scores, and we'll look at how to convert a raw score to a z-score and how to convert a z-score to a raw score. The main purpose of z-scores is to describe a score in terms of where it fits into an overall distribution of scores. And particularly what a z-score tells us is the number of standard deviations a score is above or below the mean of the scores in a distribution. Let's look at an example to think about how z-scores tell us about where a score fits. So let's say that you receive an 80 on two different exams, a stats exam and an anthropology exam, and you want to figure out how well you did in each class. You can say, well, I got an 80 in both classes, but what does that mean in relation to how well you did when you consider how the rest of the class did? In order to figure that out, we need the means and standard deviations for each class for the exam that you took. So if your score was an 80 and the mean was 70 in both classes, and the standard deviation for stats was 10 points, and the standard deviation for anthropology was 4 points. Now with this information, we can figure out how well you did in relation to the rest of the class. And we can also compare these scores, these two different scores for both of your exams in these different classes. Basically what we're doing here is we're kind of translating your raw score, the score that you had on the exam, into a z-score. By doing this kind of translation, essentially what we're getting at is we're getting these scores into the same format so that we can make a comparison. So by knowing how many standard deviations your score is above or below the mean, that's actually going to tell you more than your actual score. Particularly when you're thinking about how well am I understanding this topic? Am I understanding this about the same as everyone else's? Am I understanding less than other people or more than other people? The z-score is going to give you this information, how your score fits in the group of scores. When we're looking at z-scores, we're going to talk about a particular distribution. When we talked about the mean and standard deviation, we talked about frequency distributions and histograms. And when we were looking at these different distributions, we saw that there were some different shapes. We saw that there were some different ways that we could describe distributions, and we could have lots of different kinds of distributions for any particular set of data. When we're talking about z-scores, and once we translate our raw scores into z-scores, we're going to talk about one specific kind of distribution. And we're going to be talking about this distribution for several topics in this course. And this is the normal distribution. We'll also refer to this as the normal curve. And the normal curve has a couple of really specific properties that we're going to talk about more as throughout this topic. And the most important thing, though, to know about the normal curve is that its mean is going to be 0 and its standard deviation is going to be 1. And this is what the normal curve looks like. It's symmetrical, it's unimodal. You might have heard it called a bell curve because it has this nice bell shape. And we know a lot of things about the normal curve because these are standard scores. We know that the mean, median, and mode are all equal right at the center at 0. And we know that we're going to use this particular distribution with our z-scores. And basically what we're going to imagine here is that under the curve, we can imagine that all of these individual scores are under the curve in this area under the curve. And each of these scores representing an individual person with that score. And what we can see and how this distribution is arranged is that in the middle, towards the mean, more people are towards the average. There's lots of people in that area towards the middle where the scores are mostly grouped. So this high point in the middle represents all of those people's scores in the middle. And as we go out towards the tails of the curve, towards the higher end and towards the lower end, the edges of the curve go down. And that signifies that there's less people there. The further we get away from the mean, there's fewer and fewer people who have scores that are that high or that low, these extreme scores. And again, because the normal curve is a standard distribution, we know exactly what % of scores are in each of the sections in the space under the curve. And we're going to be using this information. We can draw an image like this. We can already said that our mean is going to be 0, so right in the middle. And we can draw a line right there down the center to mark that. And we can mark our z-scores, which are going to be as we mark each standard deviation away from the mean. And so each of these is going to be one standard deviation away from the mean, out in either direction. So +1 or -1 is one standard deviation away from the mean. +2 and -2, two standard deviations away from the mean. +3, -3, 3 standard deviations away from the mean. And so first of all, how do we read these z-scores? We're going to have 2 bits of information here. So what we're going to have when we look at a z-score is we're going to have a number and we're going to have a sign. Our number is going to tell us how many standard deviations away from the mean that our raw score is. And the sign is going to tell us just whether we're above or below the mean. So +1 would mean that our score is 1 standard deviation away from the mean and above the mean. But -2.5 would mean that our score is 2.5 standard deviations away from the mean and below the mean. Let's look at how to convert a raw score into a z-score. And so when we talk about raw scores, what this means is just what our score actually is. It's a regular score before it's been converted to a z-score. And so that's just whatever our actual score is. And in order to calculate our z-score, again, we need to make sure that we have our mean and standard deviation of the distribution that the score came from. In a problem, I might give you that information, or I'll give you the information that you need in order to calculate the mean and standard deviation yourself. So this is the formula that we're going to use, z equals x minus m over sd. And so this is going to be our raw score, x minus the mean of the distribution over the standard deviation of the distribution, or divided by that standard deviation. And so the first thing we're going to do is subtract the mean from the raw score. And this gives us what we call a deviation score, that x minus m part. The next thing we're going to do is we're going to divide the standard deviation. We're going to divide the deviation score rather by the standard deviation. And so if we put this in action, first looking at that statistics test score, if your score was an 80 for both exams, again, so 80 is your raw score here, 70 is going to be our mean, and our standard deviation for statistics is 10. So here we can see that we're going to get our raw score minus the mean, 80 minus 10, divide by 10, our standard deviation. We're going to get 80 minus 70 is 10, divided by 10 is 1. And so here, our z-score for statistics test is going to be a +1. For anthropology, we're going to use the same formula, plug in those numbers. We still have 80 minus 70 because we got an 80 on both exams. Mean was a 70 in both classes, so that's 10. Divide by the standard deviation, which here is going to be 4, and that gives us 2.5. So our standard z-score rather for anthropology is a +2.5. In order to compare these, what I always am going to suggest is draw this out. It's really easy, even if you just draw it as a number line like I have here, but I also suggest drawing the curve. I always suggest when we're making these kinds of comparisons, especially, draw it out for yourself, write notes to yourself. It really helps to not just be manipulating those numbers in your head, but to really be able to see them in a more concrete way on paper or your tablet or whatever you're using. And so I can draw this number line and I can mark where statistics is, right at that +1, z-score of +1. And anthropology, z-score of 2.5, again on the positive end. And so here I could look at this graph, this drawing that I've made, compare these scores, and I can see really clearly that I did better in anthropology. And I can have that information really only because I was able to calculate those z-scores. If I'm looking at just 2 classes that I got an 80 in, I might think that I did just the same in both, but here we see I'm actually understanding way more in anthropology compared to the rest of the class. And we can also turn it around. We can convert z-scores into raw scores. And to do this, we just kind of move the formula around a bit, and instead of subtracting and dividing, we add and multiply. And so the first thing we're going to do to convert z-scores to raw scores is we're going to multiply the z-score by the standard deviation, and then we're going to add the mean to that deviation score. And so here, again, if I didn't know what my grade was for statistics, maybe my statistics professor wants me to practice my z-scores, and so she gives me my grade in z-scores and gives me the mean and standard deviation for the class, and I have to calculate my own score. I will not do that to you guys. But if I had to do this, I could take this formula and okay, I know that my z-score is 1 for statistics, and I know that the standard deviation for the statistics exam was 10. So I can multiply that. 1 times 10 is 10. and add the mean, which was 70, and I'm going to get that my raw score is 80. And so that wraps up this topic for converting raw scores to z-scores and z-scores to raw scores. And so I hope that you got a lot out of this and feel a little bit more comfortable figuring out how to convert these scores and doing these calculations. Thank you.